Hello DE students, we are back with Understanding Digital Design for the random number generator. So last lesson we focused on the analog component of the random number generator. We are now going to move into the digital component of the random number generator. So you will remember from yesterday that we are essentially creating a board game counter or a digital die that is going to randomly generate numbers using our circuit design. So yesterday you analyzed this section, the analog section, and looked at these clock signals and how they, when we push the button, have this really intense tight-knit wavelength, and then they decrease as that button is released. Today we're going to move into talking about the digital portion, which is our sequential logic and our combinational logic sections. So that's where we are headed for today. So let's get started. So this is our schematic diagram, looking at the sequential logic section, so that middle section from the block diagram. You can see that we have three 74LS74Ns tied in here, and they are looped through with a 5-volt power, and then we have three outputs, A, B, and C. Also, we have two AND gates, and we have an inverter tucked into this circuit. So all of these get laid out and put together to create our sequential logic section. So this essentially creates a 3-bit counter with our default count range. So that 3-bit counter is what allows us to control the outputs in a way that we can get the random numbers that we need. And then down here we have the set reset logic, and this is results in a count range of 0, 1 to 110, which is what we need for the board game counter. So we need to get it dialed into 1 to 6. So looking at this is an example of counting to 1. Okay, so nothing, 1 LED. Okay, that gives us a count of 1. The LEDs then change to indicate the number 2. We also have 3, and number 4, number 5, and number 6. You'll notice that this tends to be a relationship between Q and Q naught, and rotating through those areas. Okay, so now we're going to take a look at the combinational logic section. Looking at the schematic diagram, this is our combinational logic. This is where we have to take those gates and put them together in a way that controls our LED. So you'll notice that we have these LED, or these probes, as we would put them, they would be LEDs in real life, and we have them set up in the pattern of a die. So we have 1, 2, 3, 4, 5, 6, and then the 1 in the center to be able to represent the sides of a die. And then we have our logic gates tucked in here. So we have our OR gates, our AND gates, and we have an inverter coming from the output A, B, and C. So our combinational logic would essentially be over here with the outputs A, B, and C, then going into the sequential diagram. Okay, so then we're looking at this giant truth table where you have to go through and create the different logics in order to be able to get these different numbers to display. So basically, because in the previous slide we labeled these L1, 2, 3, 4, we can then identify them in the truth table as that across the top. We then can go through and identify what we need to have lit when and create our truth table. So this is the sequence in which we would have to have the outputs and inputs come through in order to be able to create these numbers. Okay, so again, note that these numbers have the same entries in the truth table, so that means they're equal functions. So that means that they're the same. So don't be surprised if you see multiple functions as the same inside of a truth table. Okay, so now looking at the combinational logic, this is how the sequences would flow, the electricity would flow in order to be able to create numbers, the different numbers. So we had 1, here's number 2, this is 3, we're looking at 4, 5, and then last 6. Okay, so if we're going to use LEDs for the combinational logic section, it would look like this. Now, for our purposes with the simulations, we're mostly going to be focusing on using probes to indicate like this, but in a real circuit, we would be using LEDs, and when the red arrows are lit up, that indicates that we have the LED lit. So this is actually showing a count of 4 inside of this pattern. And again, you can set this up just the same way, 1, 2, 3, 1 in the middle, and then 1, 2, 3. So you can use the LEDs to indicate as well. Okay, so then now looking at this, we have our analog section, which we talked about last lesson. And then it moves into our sequential logic section and our combinational logic section and into those LEDs. All right. Okay, that is the end of the digital section wrap up. You can now go into the assignment. You're going to be using Multisim to actually set this up, run through the truth table, run through all that information, and make sure your circuits are working properly. All right, get at it.